Okay, hey guys, so now that we've reviewed how to factor, then let's go into the basics of rational expressions. All right, so hold up. Okay, a rational expression is basically a quotient, that means division, of polynomials. Okay, a polynomial is like terms, right? So this is a term, that's a term, n plus 4 is terms, 8x squared minus 2x is 5, that's a polynomial, right? And then a quotient is a fraction. So think of like a fraction, I don't know, 3/4. This is a division sign, okay? You can go 3 divided by 4, you can do 3 divided by 4, you can do 3 over 4. So that's all kind of fractions. And the word rational means fraction. Okay, and so this unit combines two of y'all's favorite math F words, right? Fractions, and factoring. Okay, probably not really, but so that's what we're going to do in this unit. All right, so some big step, girl. We're going to set the denominator, only the denominator, that's the bottom. Ignore whatever's on top, the numerator. Solve it. To solve it, we're going to probably most likely have to factor, and then we write it in what's called set builder notation. So you do this curly Q thing, and you write x bar, x, and then you write some stuff right here, and then you write the other curly thing. All right, so let me change color first. All right, so the set of all x, that's what this piece means. Okay, such that, that's what this piece means, that bar. And then x, this x, like equals 4, doesn't equal 3 or 1, is a real number, something. And that's how we read it. The set of x such that x blah, blah, blah. All right, that's set builder notation. I'll review it in a minute. So we're going to write the curly Q, x, a bar, x. We're going to write some stuff right here, and then a curly Q, curly brackets. That's what they're really called. All right, so we're going to find the domain of this function. Okay, so set the denominator equal to 0. Ignore the top. Done. Solve it. All right, we don't have to factor this guy. So I'm going to subtract 5 on both sides. All right, so this means what we did, we solved it. All right, if I put a 5 right there, this is -5, so I need to subtract 5 on both sides. Silly me. If I put a -5, let's see what happens. -5 plus 5. I get -x over 0. And anything over 0 is undefined. So what I'm really finding is the thing that x cannot be for this rational expression. So I'm going to do curly brackets, x bar x, curly brackets. It's an awful thing, but okay. And then I'm just going to write this guy. X cannot equal -5. So it's the set of all x such that x cannot equal -5. So basically it can equal any number except -5. Do another one. All right, set the denominator equal to 0. All right, that's the denominator. Ignore the top. We're done. And then we write in set builder notation. But remember, what we're really doing is finding what x cannot equal. And we write in x in set builder notation. So that's our shell. And then we take that guy and pop it in right there. So x cannot equal 0. And that's our answer. Let's do another one. Right. So when we need to factor is when, hang on guys, 1 second. Sorry, my kids called. My mom's watching them while I make these real quick. Well, I can't make them real quick. They take a long time. Okay. So we're going to set the denominator equal to 0. Whoops, let's get the right marker. X squared minus 4x plus 3. Now remember, when you have an x squared and an x, you set equal to 0. You need to factor it. When it's just an x squared or just an x, for example, x squared minus 4, okay, or x plus 3, you don't need to factor those. Those you just solve because you want x squared to equal a number or x equal to a number. But when you have the x squared and the x, or a t squared and a t, or a w squared and a w, in the same equation, you need to factor it. All right, so to factor this, there's no number in front, so I'm going to go what multiplies to give us 3, adds to give us -4. And so 1 times 3 is 3, but we need a -4, so everything's negative. And so there's nothing right there in front of the x squared. So I'm going to write x minus 1, x minus 3. And so then I set each factor equal to 0. So x minus 1 equals 0, and then x minus 3 equals 0. And I'm going to add 1 to both sides. I get x equals 1. I'm going to add 3 to both sides. All right, so remember, these are the numbers that x cannot equal. So we're going to do our shell for our set builder notation, and then we're going to write x cannot equal 1 or 3. And so this is our answer. All right, let's do another one. Ignore the top, set the bottom equal to 0. 3 equals 0. That's never true. And so since that's never true, change colors. Never true. So that means that x can equal any real number. That double R means all real numbers, just so you know. So you could write x equals all real numbers, or you could say, like, instead of the double R symbol. I'm just showing you another symbol. Not that I think you must know it, but it just saves you 3 words. Okay, what if, I don't know why this is twice. All right, moving on. Okay, so we're finding domain. Ignore the top. Always go for the bottom. We're going to set it equal to 0, and there's an x squared and an x. So that means we're going to factor it, 30. So we're going to figure out what multiplies to give us -30, adds to give us, remember there's an invisible 1 right here. So to give us 30 is 5 and 6, but we need a positive 1, so that means 6 is positive, so 5 is negative. So let's check it. -5 times 6, -30. -5 plus 6, 1. And so there's nothing in front of that x squared, so I can just write x minus 5, x plus 6 equals 0, and then set each factor equal to 0. And so I'm going to add 5 to both sides, and then I'm going to subtract 6 to both sides. All right, and then I got to write it in set builder notation. All right, and so I have 5 and -6, so x cannot equal 5 or -6. And really, I should write the -6 first, but it's going to be okay, because you should write it in numerical order. All right, so now we're going to do lowest terms. And so basically, we're simplifying fractions. So 8 over 16, I can divide everything by 8. So 8 divided by 8 is 1, 16 divided by 8 is 2. So what I really have is k over 2, and that's it. What if this said 16 over 8k? All right, so then I would divide by 8, so I would have 2 over k. All right, so keep in mind, those are 2 different things. Those are actually reciprocals of each other. I think my music in the back is a little loud. All right, let's do 8 plus k over 16. Do not do this. All right, 8 divided by 8 is 1. 16 divided by 8 is 2. So it's 1 plus k over 2. That would be incorrect, and I will be very sad. What you really need to do is this. 8 plus k over 16. You need to separate it. So 8 over k plus 16 over k, and then reduce. So 8 over 16 is 1/2, and you can't simplify k over 16. Okay, if you're going to simplify this, there has to be a number right here that is also divisible by 8. Like here. So 6, 36, and 12 can all be divided by 6. So what we really have is x plus 6 over 2. Or you could do 6x over 12 plus 36 over 12. And then simplify it that way. So 6 and 12 is really 1/2. And then 36 over 12 is 3. And so this guy is the same as this. Watch. If I split x over 6, x plus 6 over 2, that's x over 2 plus 6 over 2. And x over 2 can't reduce, but 6 over 2 can, and it reduces to 3. So I don't care which method you choose. Those are essentially the same thing. It's like me wearing my summer clothes versus me wearing my fall clothes on the same thing. All right, here, this is going to be kind of difficult to understand. So see if you can follow me. Notice they're the exact same thing, except they're in a different order. So just bear with me. Whoopsies. Bear with me for a minute. If I took this, let's get the right marker. If I took this 3 minus m and I multiplied by -1, excuse me, I would get -3, and then -1 times -m is +m. And then you always write the letter first, so it's really m plus -3. But if I change that to subtraction, I get m minus 3, okay, which is the top guy. All right, so the lesson learned here is if you have the exact same thing, m minus 3, 3 minus m, 9 minus x, x minus 9, okay, 12 plus, I mean, it's always minus, never a plus. All right, the only difference between the two is a -1, like you multiplied by a -1. So this guy is really m minus 3 over -1 m minus 3. Because if I took this guy and I did -1 m minus 3, I would get -m. -1 times 3 is +3, and that is really 3 plus -m, which is really 3 minus m. All right. So now, look, these guys are the exact same thing. So what I really have is -1. You may want to rewind the video a little bit and go back through that logic. But if you have the exact same thing, the difference of the factor is a -1. All right, I'm going to pause this. I think we have like a whole bunch. And I'm going to start a video on the next one.